Perfect. Recording now.
Cool.
Hi,
Hello, how are you?
I'm fine. Sorry, I couldn't assist to the previous classes because right now I'm in English class, so
Yeah,
that's the reason I couldn't assist. Yeah.
it's all right. We're starting.
Because
We won't be starting
I'm
till
going-
like 2.
well, I'm studying English because the next semester in July I'm going to enter to the master of that science. Yeah.
Okay, yeah, understand.
Yeah. Well, can I ask you a question?
Yeah.
Well, I have a question in reference with R. In the study plan, it says a lot of use of Python.
Yeah.
For example, they told you that introduction of Python, but I don't see really the use of R much in the study plan. So I have like question because I use R. So I have a question if I enter knowing R is sufficient
Yeah.
or they are going to use only Python.
You have some. Oh, a bit of echo.
Oh, sorry, my mic's on.
Yeah. So you got some subjects in the course where you'll need to use R, like data visualization, and you'll just need it for work, to be honest. Yeah. It's kind of hidden. It's not hidden. Like if you read this like the subject guide deeply enough, it also says some of them will have R, but then we don't have any intro courses to R offered at Monash from the faculty, which is why we're setting this up.
Cool.
If that makes sense.
And for example, that part of cloud development, because for example, when you use Shiny and you put it in EC2 in Amazon, they teach you that or not really?
They teach you how to use Shiny,
Yeah.
and then you've got to figure out some of the things by yourself. But yeah, you'll make an app in data visualization in Shiny, and then you can work out how to upload that online.
Yeah.
So they'll teach you the difficult things, and then some things
Okay.
are just kind of routine, and you have to figure out yourself. But
Right,
yeah,
cool.
R is used in I think about 6 or 7 subjects maybe in masters, maybe even more than Python. So if you want to do well, you should probably spend some time on it.
Cool.
Okay, cool. So just in the meantime, we'll start in a few minutes, but if anyone is having trouble getting their screen with session 2 downloaded and working, just let me know. Otherwise, we'll just wait for everyone to join, and we'll start at maybe 2:05 or 2:03 or something. So the recording will be in, it'll be in the same thing as yesterday, with all the with where you found the RMD file in the Google Drive. Yeah. We'll upload them both, I think, this evening, hopefully. All right, cool. So you just had 1 or 2 people join, but we might start now. All right. Cool. So I guess we'll get started here. And so we'll be using some extra packages today that we didn't use yesterday. So these are, we'll be using ggplot and we'll be using tidyr. So if you haven't installed these two, just highlight them and then run those cells so that they're installed. And that will install them. If you're having any issues loading all of these packages in, then let me know. Otherwise, if everyone's ready to move on, maybe just type in the chat and we'll move on. All good. Cool. Seems like most people are good there. We've got all that set up. Awesome. Cool. So we'll start out by reading in the housing data, the same as yesterday, where you have the read CSV function. It'll read this from online and put it into the housing data. So let's clean this. And all the variables from yesterday. So now we've got our empty environment again. And we go Control Enter. Oops, sorry, I haven't loaded them in myself. And we run Control Enter on this, and it will save our housing data in here. So then we can view our data frame in the same way as yesterday if you want to have another look at that. So we just get one of these, Control-Alt-I, view. Data. We can see the same data is all read in and all good. And so we're going to start out here with dplyr. So we used some dplyr functions yesterday, but I'm going to introduce you to a couple more. These are really good to sort of summarize data and prepare it for visualization and to get sort of interesting insights out of it, some basic insights. So if you've used SQL before, some of these functions might be familiar, but it's in a slightly different sort of format and different syntax. So select, we covered yesterday, it'll select different columns. So here we're looking for 3 columns. We're going to get suburb, price, and bedroom 2. So if we just want to select 3 columns, this looks a bit cluttered. Maybe we're only interested in the 3. We can run this, and we'll have just 3 variables here. So we'll have our housing prices in just the 3 columns. So we'll have a new data frame called housing prices, and we've taken this and done this. Node package called ggplot2. So make sure you've installed it first. Is it not better to use data.table? We can, but this is how it works. Sort of, it works better using tables or these data frames. It's just the library works better and it's more simple. through an error while installing that. Maybe try without ggplot. Maybe try that. That should work. Awesome. Cool. So now onto filter. So selecting data works for columns, but if we want to use the rows, we use filter. So if we're only interested in the houses with one or less bedrooms, then we can use this function to select it. So here we have housing bedrooms, which is we're going to save. So we're going to take housing data and filter it only when the bedrooms are less than or equal to 2. And if we run that, Control Enter, we can see that this comes up here and we've got only houses now with 2 bedrooms. So we've cut down about 9,000 different observations. So that'll allow us to do that. And so again, if you want to look at it in another tab, use the view function. So here, see if you can find all the houses with the date less than 9,000 with the building date. So if we look here, we can see that the date built, the year built is under year built. So we want to get housing data and type it in to filter and then year built is less than 1900. Give us a list of all the houses that were built before 1900 that were sold in the data frame, in the data set. So we can start getting sort of finding different interesting features from the data set by using these filter functions. So that's the Magritte pipe from last session. So if you've loaded in the packages, the Magritte pipe should work. So if you've used these, if you've installed these packages and then loaded these packages, it'll come with, I think, dplyr. So make sure you've run this code by going like this and then going Control Enter. And then make sure you've also installed them first if you haven't. And then, so that's the Magritte pipe. That just means take the housing data and put it into filter. So in session 1, we covered that briefly. It just takes the data and takes this and puts it into this function. So we can take that and just keep bouncing it along. So now it's okay to extract single sort of rows and columns, but if we want to summarize it, then we're going to have to use another function. So say we want to find out which suburb is the most expensive, so the highest house prices. So we can sort of write a loop or something that can take it, the average, but this dplyr gives us syntax to do this in sort of 3 lines. So first we specify which variable we want to group by, and then we can summarize each group. So we want it to form groups of suburb, and then we want to summarize it, and we want to summarize it by the average price. So this tells us to take the housing data, group it by the suburbs, and then summarize it by the average price. So if we run this, we'll get a table here that has the average price and every suburb. So the average price of a house that sold in Abbotsford was this, in all of these. So you can see that. So now say we want to take these and we want to arrange it because this is currently in alphabetical order, so it's arranged in the same way the data was before. But this might not be so useful to have these 32 suburbs because we'd have to manually search through them. So we're going to use arrange. So here we take the housing data, we group it by the suburb, we summarize it, and then we say that we want a column called price that's going to equal to the mean of the price. So here we had mean price was our column, but we can rename that column by using this. So the price is equal to the mean of the price. And then we want to arrange it by descending order of prices. So we can run that and we get this. So here Kooyong is the most expensive, Canterbury, Middle Park, Albert Park, Brighton, Baldwin. So we've managed to figure out from the data set using the summary and arranging, just 3 lines of code, we can figure out what the most expensive suburbs in Melbourne are. All right, so has everyone run up to this point? If you're all good, you understand, just let me know in the chat so that we can sort of move on. Otherwise, yeah, if you have any issues, let us know so that we can fix them. All good, thanks, Dan. Cool. Awesome. All right. So if we got nothing else, then we'll do mutate. So mutate creates a new column. So say we want to find the average price per room for each council area. And so say we want to count a bedroom as 1 room and a bathroom as half a room. Then mutate creates a new column called price per room, which is equal to the price. So we can use mutate to create this. So here we take mutate and we take the housing data and then we mutate it so that the price per room is equal to the price divided by this bedroom plus half of the bathrooms. So this will tell us how expensive the price per room is. And so when we run this, we'll see that at the end of this, there's a column on each thing that tells us how much we spend per room on each house. So this will be like, well, this house cost $650,000 per room if we use this definition. So we can figure out all sorts of things by entering in our own custom formula here. And so we tell it what column row name we want to create, and then we tell it how much, and then we write the formula in terms of other columns, right? So we want to take the price and divide it by the bedroom 2 plus half the bathroom. Cool. So putting this together, we can try and find council areas that have the most expensive price per room, right? So note here that we can sort of chain it together. So you can say, take the housing data, mutate it. So create this column that has price per room, which is equal to this. Take that, group it by the council area, summarize it. So the price per room is the median of the price per room, and then arrange it in descending order. And so if we run this code here, we'll get this data frame, which has each suburb. And so this is real world data, so it's a bit messy. So you might notice that our most expensive thing has the council area unavailable. Maybe that was a ski resort or something where there's no council, but there's only one property sold like that. And Burundara was the second most expensive, and it had a lot of properties sold there. So this, by piping it through like this and telling it what to do at each stage, it tells us what to do. one function here that I actually haven't explained is the n function. So we might summarize it by something like the median price per room. But you can also add an extra argument that says, okay, now create another column called count. And this n will just be the total number of records. So it'll group by council area, then it'll count the total number of records for that council area. So the number of house sales in the council area or whatever. So we've got here, price per room, count. And so we can create tables like that, which will sort of show this data, this summarized data, so that we can, see, say get insights from the data about sort of where's more expensive, where's less expensive, how many rooms there are, or basically anything I guess you can think of. So see if you can find the suburb that has the oldest houses. So you can get some sort of minimum or maximum. You can use, say, min on the housing date, or you can use median, I guess, the median oldest house or the oldest house. But yeah, I guess you can copy some code here. You can copy this code from up here and say, okay, so then we want to figure out, group it by suburb and then summarize so that the oldest house is the minimum of the date built, I think it's called, year built. It's the minimum of the year built, and then maybe arrange it by that variable. So I'll give you a couple minutes to do that. And if you have any questions, just write it in the chat or feel free to unmute yourself as well. All right, so if you've managed to do that, just let me know. Otherwise, we might go through the solutions in a minute. And we'll just write how to show you how to do that. Yep, all good, done. Okay, awesome. All right, cool. So we'll just quickly go through a solution. So here we're going to go housing data. We're going to group by, and we want to group by the suburb. We're going to that, and we're gonna summarize. So oldest house equals to year built, and then we're gonna arrange descending order by oldest house. Sorry, we don't want to phrase it in ascending so that the oldest comes first. Then we'll run this. And here we are. So Mount Evelyn as the oldest house, just that. The shortcut key, Control Shift M. So, is this right? M for Magritta. Cool. So yeah, that'll like that. So this will drop all columns, all rows, sorry, with an NA value in the column. So if we want to drop all of them that don't have an entry for year built, we can go control here. And ages housing will now be a data frame that has that shows that removes all of the ones that don't have an entry for year built. Sorry, I must have made a mistake before. Anyway. So it'll drop all of the houses without year built. And so see if you can create a data frame that only has houses with land area above 50 square meters and find the cost per square meter in each suburb. So we'll do that, and that'll be the end of the data frame manipulation section, and we'll go on to graphing. So if you have any questions, just let me know. Otherwise, we'll go on in maybe 5 minutes at the halfway mark. Yeah, so if you're done, just yeah, let me know. And so if everyone's done, we'll keep going. Cool. So these ones here, awesome. If anyone had any issues, I'll go through them. But otherwise, just let me know. Otherwise, yeah, otherwise we'll just go into graphing. Awesome, cool. So onto graphing, we're going to be using a totally new package now called ggplot. And so ggplot can create objects, and then we can add different geometric objects, which makes graphs onto them. So we're going to use some quite simplified data here. So we're going to take the housing data that we've just used, and then we're going to move that onto, we're going to drop the NAs, we're going to filter for Richmond, where we've got more than 0 bedrooms and the land size is greater than 0. And then we're just going to select the housing type, the bedrooms, the price, and the building area. And then this one will put our type as a factor. That's just a way of storing it. So if we want it to be categorical, we can use this. So the as factor will tell us that we're going to use categorical variables in our things. So we can run this and view our simple houses data. And we'll just have the houses in Richmond that have sold. We'll have their price, we'll have their area, we'll have their bedroom, and we'll have their type. So the type here, H is for house, U is for unit, and T is for townhouse. There's a few T's, but mostly houses and units, and then bedrooms and price and area. So now we're going to create a ggplot object using this data. And so what ggplot does is it takes the data, and then we specify a function called AES, which is short for aesthetics, and it'll tell ggplot what elements of the data to map onto what items in the output. So it'll basically be saying, okay, the x-axis here, so in our aesthetic function, is going to be the building area. Our y-axis is going to be the price, and the color is going to depend on the type. So I'm going to create a ggplot object called myPlot. It's going to call this ggplot function, and in that function, we're going to say the data is from simple houses, and the aesthetics, or the x aesthetics is going to be the building area, the y aesthetics is going to be the price, and the color aesthetics is going to be the type. And then we can add different kinds of objects onto it. So for example, we're going to add points onto this now. So we're going to do this, I'm going to run it, and that'll create a ggplot object. So it'll be in here next to our data. So you can see we've created this ggplot object, and then we're going to plot the plot here. And so that'll come out here, and it'll have a plot where this is the price, this is the type, and this is the building area. So we can see that the units here are generally quite cheap and small, but there are some big units, and we can see that most of the houses sell for over $1 million, and they tend to be a bit bigger, but even the small houses are more expensive than the small units. And then there are some really big and expensive houses up here, and the townhouses tend to be sort of scattered in this data. Yeah, so we can kind of visually get some sort of investigate that data. So yeah, just make note of the syntax and how the AES function is inside the ggplot function. And so that will let you do that. So we can add different kinds of geomes. So here our geome is a point, so it's a geometric object, and the geometric object is going to be the point. So we tell it that we want to place points where X is the building area, Y is the price, and the color is the type. And we're going to use data from simple houses. So that'll create that plot. But we can also do like maybe 20 different types of geomes. Far too many to describe here. You'll probably have to Google them when you want to use them. But we're just going to be using line plots, and we're going to be using bar plots and scatter plots. Just three kind of simple plots that I'm sure everyone's seen. And so line plots are excellent for time series data. And so we're just going to run through a quick bit of line plots here. So if you run this, there's a package called Lubridate, which just makes dealing with dates easier. Just run this one. It shouldn't take long to install if you don't have it. So this will try and load your library, and if it isn't there, it'll install it and load it for you. And then run that, and then I'll just explain this, I guess, while that's running. So we're going to create a data frame called our foregraph1. We're going to use the housing data. We're going to group it by month, and then don't worry so much about this function here. It's going to take each month. So the month is going to be as a time thing. It's going to take the date variable when it's in that format, and it's going to take it to the floor of the month. So it'll group by each month, and it'll group by the region name, and then it will summarize it. So what we're going to try and create here is a graph that investigates the different regions and how their sales prices changed over time. So we'll create this, and then it'll summarize the average price, and then we'll see that data in a second. Oh, God. Sorry, I haven't run this. Okay, just gotta run that. And then this will work here. Beautiful. And we can view the data frame we just created in here. So we'll have the average sale price in the Southern Metropolitan region in January 2016 was this much. The average sale in the Eastern in February 2016 was this much. And we'll have all of that data here. So the month, the region, and the average sale price for that time. So we have this sort of time series data frame. And now we're gonna run it as, we're gonna plot that data. So we wanna create line plots. So we're gonna wanna create X to be the month. So along the X axis, we'll have our month. Across the Y axis, we'll have our price. We're gonna group it into region names. So a new line will be drawn for each region name. And the color, the lines are gonna be colored also by the region name. So they're gonna be different colors. If we take out the color, you can see they'll all just be gray. And you won't be able to tell which region is which. And then once we've specified our aesthetics and our data, so here the data, first argument's always the data. And then after that, it's the aesthetics, and we'll have that. And we're gonna add on, we're gonna tell it to draw a line graph. So we're not gonna save this, but we're just gonna show it straight away. And it'll show this graph, maybe make it a little bigger. Here we go. And so we can see this along here. We can see that the most expensive one has always been the Southern Metropolitan, and only later on do we get the data from the regional areas: Western Victoria, Northern Victoria, Eastern Victoria. So there we've created our line plot. And there we go. And so this is one thing where we're going to investigate if the distance affects how much a price sells for. So the distance is the distance from the CBD in Melbourne. And so we're going to take, for graph 2, we're going to make a data frame with that data. Take the housing data, we're going to group it by the postcode. We're going to summarize it. So if you have 2 arguments, we're going to make 2 columns. So we're going to have one column is going to be the mean price, and the other column is going to be the mean distance. So we run this, and we can view it if we'd like. So I'm just going to So we're going to have our postcode, the average price, and the distance from the CBD. So you can see that they can get here, see each postcode. And now we're going to plot that to see if there's a variable. And so we've taken this, the data's here, the aesthetics, and we're going to add points. And then here's another one, another geom. So geom smooth will fit a line. So the method is linear model, and standard error is false. So we're not going to show confidence intervals. We're just going to fit a single linear line. So geom smooth will fit a line to a scatter plot. So if we run this here, we can see here that there is actually a relationship. The houses are cheaper the further away from the city they go. So there's how to fit a line to your data. SE is standard error. So if we take this out, we'll get error bars. We set this to true. We'll get error bars. And it'll estimate the sort of a 95% confidence interval around that line. Bit of statistics, I guess. So that's how to do that graph. So see if you can write some code now, maybe in the next 5 minutes, or maybe the next, just until people are done. Then just some code that can do this, investigates that sort of question. Okay, this may be a kind of stupid question, but data frame manipulation can be done in SQL or another database language. So why use R? So that's quite a good question. So R works on R objects. So it'll work on objects that we have in here. We can actually connect it to a database. There's a library that lets us do this. And so the library will let us translate this dplyr into SQL. And you can use SQL statements as a function in dplyr. They're quite similar, but to me, this code is much simpler to read, and it operates on R objects, so within R. So we don't have to be doing SQL and then doing other stuff. We can just do this manipulation straight in R. But I guess, yeah, if I mean, you can do similar things many different ways. But this, yeah. Yeah, and we can also use this to set up sort of functions. So we can save this as a function, and we can use it for like feature engineering and machine learning and stuff like that. So yeah, if you manage to do this, just let me know. I guess, yeah, wait for maybe till 2:48, 4 minutes. And then, yeah, keep going at 2:48. All right, cool. So if anyone's had any issues, or if you've managed to do this, creating a chart that lets you investigate sort of the distance versus the price, then yeah, that's good. But if you're still struggling, let me know. So, sorry, the area. Yeah, if the area is related to the block of land size. So go into housing data and find the land size. And so you can basically just do this same stuff. And you'll put in here the land size. And then here, and then we don't necessarily need to view it, but and oh, there's some things here, but you see a slight. You see that this is positively correlated, but there are some outliers. So we can filter this to remove the outliers if we'd like. So we'll filter it and we'll say land size is less than, say, 5,000. So, filter the land size less than 1,000 and plot it again, and we can see that we do have a positive correlation, but perhaps not so strong. And so here's some more code if you want to customize your graphics. So to be able to make sort of presentation style graphics, and we can create this one. So we're going to create a plot that finds the 10 most expensive suburbs. So we're going to take this, we're going to take the housing data, group it by the suburbs. Average price is the mean price, and we want to count how many observations we have. We're going to arrange it by the average price. We're going to filter out where there's less than 10 observations, and we're going to take the first 10. So that'll create our full graph data frame, and then we're going to plot it. And so you can really customize ggplots. And so all of these will do different sort of customizable things. And so we run this. We can see our house price plot, and it will have, it'll look like this. It'll have average house sale price, and we can see what the 10 most expensive suburbs are. Sorry, my screen's a little bit small. But we can see here in this image, we've got the average sale price, and we've got the 10 most expensive suburbs. So these are all sort of things that we can customize. So here we've got the data, the aesthetics. We're going to reorder them. We're going to reorder suburb by the average price descending. We're going to take, and the Y is going to be the average price. So that way we can scale them from the top down to the bottom. We're going to use G on bar. Stat is identity. So that one will just say, just draw single bars for each identity in our X column. We're going to fill it. So we're going to make the color steel blue. This is steel blue. We're going to use the classic theme, which takes away the background checks, so it's clean at the back. We're going to relabel the text. We're going to take the angle of the text to be 60, and we're going to move it a bit across. We're going to remove the x-axis title. We're going to remove the ticks on the x-axis, so the little lines here. We're going to give it a title, and we're going to put the title in the middle. The Y label is going to say average house price. Then we're going to scale it so that it's fully expanded. We're going to take the labels and make it into dollar format. And then we're going to put our title on the most expensive suburbs. So you'll probably have to do a bit of Stack Overflow to get these sort of things, because there's lots and lots to remember. But this just shows you how sort of customizable ggplot objects are. And we can really sort of tell it to do whatever we want. So I guess that's the last bit of the thing. So I guess to challenge, you can continue investigating the data. So this is real world data. So see if you can get any sort of any cool graphs. I'll keep investigating, and you can create a graph that investigates the relationship between the age, the house, and the sale value. So if you have any questions, let me know. Otherwise, yeah, we'll be closing. Jeremy might say some stuff. He's the president of the club. And otherwise, yeah, thank you everyone so much for coming. We just have some stuff here. So what's next? So if you like the house price analysis, you can try this competition, which you can do sort of competitions based on this sort of stuff.
That's a week 2.
If you want to take this, take these subjects, which will teach you more R, way more R than what I can teach you. This one particularly will teach you a lot more about ggplot and visualization. And come to our datathon in week 4. So Jeremy, two. Jeremy will talk about that for a little bit now. And yeah, thank you all so much for coming. Yeah, we'll see you at our next event. So yeah, keep an eye on the MDSS events page. Thank you so much.
Hey all.